within those areas will get bigger. You can see the details of this operation in the following code. The name of the function, this is kernel or structuring element. An opening operation performs an erosion followed by a dilation using the same structuring element or kernel for both operations. So opening is an erosion followed by dilation using the same kernel. In this way, erosion can be applied to eliminate small groups of undesirable pixels, for example, salt and pepper noise. Erosion will out of the image indiscriminately. By performing a dilation after the erosion, we will reduce some of these effects. You can see the details of for we use this function morphology ex. This is the image. This is the kernel. Sorry, this is the method. The method is the kernel that actually this is the operation, I should say, because we use this function and for things. I will show you morphology ex. So I will show the function morphology. So this function morphology it does different operations. The are this. It can if both operations is zero. If you use more dilation, is you if you use more open and if you use more closing and then it is followed in modulation, we have more is source minus an opening. So cat which is closing minus SRC. Morphology EX UI different operations morphology. Here we use it for opening. But its opposite, the closing operator can be derived from erosion and dilation. In this case, operation performs a dilation followed by an erosion. A dilation operation okay. Sound has a problem. can you hear my voice clearly or no? Uh, the students that don't have my voice clearly, so there is a problem from their side, I think. Yes, but low. Okay, I try to now. Yes. Okay. So closing is a dilation followed by an erosion. A dilation operation is commonly used to fill small holes. So we use a dilation first. It fills small holes in the image. However, the dilation operation will also make small groups of undesirable pixels bigger. So this is a side effect. But the operation on the image after the dilation of these effects will be reduced. So for morphology, for closing, we use again morphology, but morphology EX, but we put morph close. So we have also morphological gradient. It is defined as difference between the dilation and erosion. But for applying it, we again use morphology EX. We just put here morph gradients. Top hat is put image and the opening of the image. We again use morphology EX and we put here morph top hat. And black and hat, it is defined as the difference between the input image and the closing of the input image. It is again performed by using morphology EX function. We just put here morph black hat. So what is a structuring element? In connection with the structuring element, we provide get function or kernel, which is a numpy array of type u int a. Two parameters should be passed to this function: the shape and the size of the kernel. OpenCV provides the following three shapes. If a rectangular kernel, you use morph rect flag. If you want to use an elliptical kernel, you use morph ellipse. And if you want to use a cross-shaped kernel, you use the flag morph cross. So there is an script morphology. We play with different kernel size and shapes, morphological transformations and images. So wait a second, please. Can you hear me? Can you hear me or not? Can you hear me at the moment? Okay, good. So I opened the morphological operations. Let me first run this. I press F5. So we have different images, original images. Test image 1, test image 2, test image 3. Test image 2 is a noisy image of the test image 1. Then we here we want to use type of with the size of 3 by 3. Okay, show you something. So let me explain to you something. So let me run this line, this part. I click here, it selection, it uses as kernel size is not. So I define kernel size. So I run. So now previous one again. Oh, and kernel size. Okay. This is kernel size. Okay. It's a 2D array. All pixels are 1. Okay. If I say that kernel size, I change it to 5, and then I run get structuring element and more correct. Kernel size is more correct, but it's 5. Here it's a cross. So let me check the cross again. I search cross. So it's here. So I press 9. So this is a cross shape. You see, 5. It's a 5 by 5 array. You see this column, all values are 1 and others are 0. So it creates a cross or a plus sign. Okay. So in this figure, we use if I use a size 3 by 3, So I should change kernel size to 3 by 3. So I run it. You see, it's like this. Okay. So in this script build kernel, it returns a specific kernel to use in the morphological transformation based on the kernel. This is the build kernel. Okay, we take the kernel type. For example, what is it? For example, C2 morph ellipse. Okay, this is the type. And we also send the size. For example, it's 3 or 5. So if kernel type is ellipse, then we call get structure with a flag more and the kernel size. If it's cross, we again get structure. If it's rect, then we call it. Note that when we compare kernel type with ellipse, if come here, it's that whether it is more cross. If it's not, it goes to this line. So the only option then is OpenCV just has these 3 types of structuring elements. Okay, so it builds the structuring element with the type and with that it receives. Then it returns the kernel. Okay. So also we have function. We have arrow. It takes an image, kernel type, kernel calls build kernel, which it apply using this kernel type and this kernel size and returns the result. It is the same, just we put the size dilation, the kernel type and the kernel size that are given to this function. We have closing kernel size, so it has it performs closing and returns its opening with its same, just we put open. Other things are fine and opening. It first applies a closing results with ing, then it is applied an opening. You see, opening is applied to the closing ing. The results of this operation. Closing and then an opening and returns the results. This is the vice versa, opening then closing. So we have a general operations. It is explained here also. The morphological operations dictionary contains all the implementations. will be as follows. So the key is erode, for example. The key is erode of a string, and the value is the function name. For example, this is the opening and closing. This is the function name. You see, it's here. We put this string is the key, and this is the name of the function. You see, the names of the functions all are here. Okay. Can you see my screen or no? If you see my screen, please send one. Good. In operation items. So let me show you. If I select these morphological operations and items, I press F9 to run this. Items of the dictionary, we also have an integer. What will be the K and V? So K is 4. Okay. So if I run this part again, okay, let me undock this. If I click undock, make this bigger. So you see index is 0, 1, 2, 3, 4, 5, 6. And the key the first time is erode. The value is function. When the index is 1, it means I is 1. So the key is dilate and the value is function dilate and so on. Okay. So here for just prints the keys and the values of the dictionary. Now it all and the results will be. Let me check it. Test all images actually loads all images. 3 test images, test PNG. We save this in a list with name image names. Pass is to go to the our script images with respect to current working directory is. So here we create at the beginning list. Then for has three, so have index for each one. So index image will be image, which is at the beginning. Test1.png. So then we have this, and then we append it to this list. We read the test tree and append its array to test morph images, and this function test morph images. So this function images. So it is in this line. When we load all the images, we call show images. We send this to show images. The show images, I also show this one. So its function is here. We have images, title, and pose. Let me check it again. So this image, and we say put in the column 1. With a loop, and then we call show with matplotlib. So for each image in this array, the image is displayed. We create the title. We put the title, and we concatenate underscore and a string of index name with the title of the first image will be title, which is sent. It is, and for the third one, it's 3. Okay. So we position is 1. Index is 0 in the beginning. We multiply lengths of the morphological operations. Let me check when morphological operation. I didn't select close parenthesis. So it's 7. So so 0 multiplied by 7 is 0 plus 1. 2. So the image is shown in the second part of the subplot. In the second part of the subplot. Let me check what is the pose here. The pose in here. Oh, it's 1. Okay. So when it's 1 pose plus this is 0, and then let me check. Oh, and morphological operations plus 1. And then so it is 7 plus 1 is 8. It is multiplied by index image, which is 0, plus post. So the results of this calculation is this calculation. The results of this is 1. The first image is shown here in the 1. But the second image, so for the second time that this 4 is performed, index image is 1. So I told you that the length of morphological operation is 7 plus 1, it is 8, multiplied by index image, which is 1. So the result will be 8, and then plus with pause, then it will be 9. Okay, it will be 2. So 2 multiplied by 17. So the next image is shown here. So showing here that we have 4. By this 4, we apply each morphological operation to all test images. Afterwards, show them. So we use morphological operations items. I will be 0. K will be the key. For example, the first key. What is the first key? The first key is error, the string of error. Index is 0, and the value is error function. Okay. So we have 3 values here. So 0, string error, function error. So we call apply morphological operation on test images. K is error, the string of error. Here is the kernel type. We want to use rectangular here. The kernel 3 by 3. So the morphological operations are applied to all test images. And then we send the results to show images. We also write here K, which is a string, and then we say I plus 2. I is the 0 at the beginning, so it means that in column 2, the results of this fourth state are list. If you look here, this is the second row. So it apply an erosion results is displayed here. The results of applying erosion to this is shown here, and the results of applying erosion to this will be shown here. So if you look here, applying morphological operations, let me show you its code. So you see here, then again we have a 4. We morphological operation. Note that this one doesn't have s at the end, but here we have morphological operations. So we say here variable name doesn't have an s, so it's a root. Okay, it's a root. Then we say the string of a root, morphological operations and the index a root. So this means the function of a root. This means the F9. So let me say that morphological operation without an s, it is equal to a root. Then I write this again. So this is the function a root. Okay, we put the logic, I put here dilate, then the result of this will be function of dilate. You see, then the value will be function of the root. So this part function. So a root function is called for the image is the first image in array image for loop for the first time. So the results of applying erosion is saved in result. Then we append this will be the same for the second and third images, and then the results will be append to the list, and the list is returned. Okay. So the results are returned. Also, it shows images in which in column 2. 2 means shows images in column 2. So we repeat it. We repeat this time. This time you compare this line with so kernel size of 5 by 5. Here we used 3 by 3, but now here we use 5 by 5. Yes, I think these seem difficult, but if you practice and you study, you will understand them. Okay. Again, note that the user side 5, the results. Oh, it's another feature. Okay, it's another feature. Here we apply all the operations. You see, here when we use kernel 3 by 3, We do erosion, we do dilation, closing, opening, gradient, closing first, then opening, opening, then closing. So this is for the first image. For the second, we use more fresh, but the kernel size will be 5 by 5. For the third one, slash and its size is 3 by 3. And for the last one, for the fourth one, the type of stable element size is 5 by 5. So each of these fours, each of these loops, each time we have one operation. That operation is applied to all three test images. Then it goes to the second operation. The second operation, what is the second operation? The second operation is dilation. It applies all three test images, then choosing, then opening, then gradient, and so on. So it is, I think I explained everything, but other parts are same. Any question? Okay, you read, then it will be easy. So let me know. Key of the dictionary identifies the morphological operation to call when the corresponding key is used. For example, if you want to call error operation, we must perform the following. We should write morphological operations. Key is the string of error. But in the code, we say apply morphological. In apply morphological, here in this function we put here a string of error. So in both image, kernel type, and kernel size, in fact, they are the parameters for all the functions of the dictionary. Logical operation function applies all the operations defined in the dictionary to the array of three. Find shows find is all the images contained in the array are allotted. So a specific implementation. So you should we have plenty of comments. For example, these two comments explain that show the morphological operations. For example, here it says reload all the test images. So in each location, there are a lot of comments that you can read them. The script plots sizes are tested. For example, the following screenshot, you can see the output when a kernel size of 3 by 3 and a rectangular kernel are used. As you can see, the preceding screenshot is processing the images because you can get rid of some noise which is the proper processing of the images. Additionally, morphological operation can also be used to deal with imperfections in the structure of the image. If you look in these images, here noise, but here the noise in the background, in the black part, are removed. Here, but look here that in the foreground, the noise actually increased. But for example, here when we use opening in the background and also the noise in the foreground, we can't. It is weaker now. It's closing and moves objects of the background. Okay. So, any question? Our course is until here. Color spaces. Color spaces. If you don't have any question, I think I should stop here. So on the page 260. You hear me? Can you hear me? Until page 260. This is for today. Color spaces. No question? Okay, when I have time, I will score the exam. No question. Very good. So, في أمان الله. Goodbye.